This is Common Test 1, 2015, question C1. We have a thermocouple that's connected to a millivoltmeter. When it's minus 10 degrees, it's 5 millivolt. When it's 25 millivolt, it is 110 degrees Celsius. What is the temperature when it's 10 millivolt? Now there are several ways to do this question. So today I'm going to go through 3 different methods to get the answer. Let's start with the first one. Method number 1. We can use the formula that we have been given. E is proportionate to change in theta. And we write out the formula K theta 1 minus theta 2. Given that the difference in temperature gives you a difference in EMF, we can actually take 25 minus 5. Minus 10. Take note of the negative sign when we minus. $120. Okay, when we make K the subject, we will be able to get the constant K in our question. You don't have to evaluate this, you can leave it as it is. Then we can go on to the next part where we find our unknown temperature. So we can take the difference again between any of the two voltages. In this case we are using the 10 millivolts now. We have just successfully calculated K. You can see that we will take the matching temperature, 25 to 110, 10 to unknown temperature. I put the unknown temperature corresponding respective to the voltage. So this is for this is for this. Okay, let's solve this equation. Making this the subject, 10 times 120 90. Okay, 110 minus theta is 90. So theta equals to 90 minus 110. Don't forget the negative sign. When you calculate that, you get the answer is 20 degrees Celsius. Okay. Now a second method that we can do is, first we can find where the co-junction is. Because in this question they give you a hint right at the top here that the co-junction of the thermocouple is not kept at 0. So we don't know the co-junction as well. So some of the students, when they come to this, they are stuck because they don't know how to put in the second number. So let's try it out. Let's write the formula down again. Hot junction minus cold junction. But what we do know is we know two temperatures. So either we can put it down like this. This was given as negative 10 minus an unknown temperature. And we can have a second formula. And in maths, when we have two formulas, we can solve it simultaneously. So using whatever methods that you want, you can solve for theta C. So let's use one method, which is to divide the two formulas. Let's take this divided by this. So 2 divided by 1. K will cancel out to leave this. Be very careful when you work with long questions like this because there's a high tendency to make mistakes. Okay, and we move around the values. And we find that theta C is negative 40 degrees. So let's substitute this back. So 5 equals to K minus 10 minus negative 40, so plus 40. And we found that K is 5 over 30. Let's leave K as such. The last step requires us to calculate what is 10. We know K. We know the unknown temperature. We know what is theta C. We can solve for this. So finally you'll get 100 over 5 minus 40, which is also 20 degrees. So you can see the answer is the same. Now this may be a bit long for a 2 marks question. So what's the last step that you can possibly use? The last step will be in terms of a ratio. These are the information that we know. 110 degrees, 25 millivolts. 5 millivolts is at negative 10 degrees. What is the value of the temperature when it's 10 millivolts? You can see that we can use some form of ratio to solve this question. And how can we do it? By finding first that between 110 to minus 10 degrees is 120 degrees. It is given by the difference here, which is 20 millivolts. So every 5 millivolts gives you 30 degrees. Since this scale started from minus 10, so theta will be given as minus 10 plus 30, which is 20 degrees as well. So whichever method you use, you should be able to obtain the same answer.